Hello all, welcome to the part 2 session of SLR parser. So in the previous session, we have stopped exactly in go to I2 comma capital C, right? So I'm moving this. So if you can see that, I'm going to move this value go to function and capital S tends to capital C dot. So you can able to find that this capital C after a dot. So this is the end of statement. So I'm going to mention this as a new iteration number, that is iteration number 5. Right. So we still have more process to be done in iteration numbers 2. Right. So let me take you there. Again, I'm using this go to function, go to I2 comma small c. We have a small c left over in I2. So again doing this small c dot a capital C. As you all know, whenever you have a terminal and a non-terminal, we need to expand this again. So I am doing the same similar way. So C tends to small c capital C and C tends to dot. This is not a new iteration because we got the same iteration like this and the iteration number is 3. If you got the same iteration, kindly use that as iteration numbers. Whichever the iteration number is previously existing, you can take that iteration number and use it, right? Now I'm going to the next iteration, that is go to, still we have D there, so go to I2 comma small d, right? So when I am going to this particular way, so C tends to D dot. So this is also not a new iteration. We got this particular production ending already, and that number is iteration number 4. Whichever is existing, please take that value, take that iteration number and put the iteration same number so that it will be very useful in constructing parsing tree, right? I'm going to iteration number 3 now. Go to iteration number 3. So iteration number 3 is null here, right? So we are going to take each and every value, right? So iteration number 3 comma capital C, right? So what is capital C in iteration number 3? So we are going to take this C tends to small c dot, sorry, capital C and a dot. So you can able to see that small c and a capital C is a new iteration. So mention that what is the iteration number is new. So we can able to mention that over here, right? Again, I am going to go to function iteration number 3 comma small c, right? So I am deriving the same iteration. C tends to small c dot a capital C. You can see here a terminal and a non-terminal. So we are using the same rule, expand. C tends to D dot. This you all know, this is not a new iteration. This is iteration number 3. So I'm mentioning the same iteration over here, right? So I'm going to the same function again using this go to function. I3 comma small d. So I am using this iteration, so D dot. This is also not a new iteration. We got this iteration. The iteration number is 4. Now the iteration number 3 is over. So I am going to go to iteration number 4. Iteration number 4 is nothing is there to be values has to be precedent. So I am mentioning it as null. Right, whichever is null, that is we don't have any precedence value to be moved from left to right, then it is called as ended. So again I am going to iteration number 5. Iteration number 5 is also null. Again I am going to iteration number 6. Iteration number 6 is also null. But you can see that I am again going to iteration number 3, which is already solved for many times, and we still got this iteration number 3 repeated for many number of times. That means it is a loop which never ends. So I am stopping all these values whenever the original prediction rule has got all these iterations. We need to check all the iteration. We need to check these iteration values with the original prediction, that is a given grammar. If all this process has been ended, then we can able to stop this. Now slowly we are moving into step number 3, that is constructing a parsing table, right? So this is going to be an interesting part. So we are going to use all the iterations whichever has been solved previously, and we are going to construct this table. That is step number 3. Okay, so let us move on to the next topic, that is parsing table. This is step number 4. Now I am going to construct this table based on the previous step, right? So I am going to take all the states. How many number of iterations we got totally? So we got iteration number 0, iteration 1, 2, 3, 4, iteration number 5, and iteration number 6. So this is what this particular row fills with, and all the terminal and non-terminal values we need to take. So terminal is in this particular given production, that is small c, and small d. You need to add dollar also here, because dollar symbol is going to be a rule number 2 which has to be added in every single parsing table. So I'm adding it, and capital S, capital C. These are all the symbols we have in that particular production rule. Now I am going to check each and every values and what is the result. See here, I am going to check I naught comma small c. I am going to check this I naught comma small c in goto function. So in goto function you need to check this. So let me show you one simple example. See here, this is where I naught comma small c. So what is the result we got is iteration number 3. This number has to be mentioned over there, right? So the process we got is I naught comma small c. We got shifting symbol, that is it is not ended, right? So I am going to mention it as S3, right? S represent shifting and 3 represent the iteration number. In the similar way, I naught comma small d, we used to get dollar, right? Let us complete this I naught comma dollar. There is nothing is I naught comma dollar, and I naught comma capital S. So we have this symbol. So you can represent this, that is terminal and a non-terminal with S or E, A or B, whatever this is, that doesn't matter. So the iteration we got is E1. I naught comma capital C. The iteration we got is E2. You can able to check each and every process one by one, so that you can able to see that. So we got this iteration number 1. Iteration number 1 is an augmented grammar. That's why I already told you. It is the only process which comes in this dollar state. Whenever it finds an I1 and it is meeting with a dollar, that particular state is called as accept state, right? So this is what rule number 3, right? So let me take you to the iteration number 2. Iteration number 2, you can see that I2 comma small c, we got S3. I2 comma small d, we got S4. In the similar way, I2 comma capital S, we don't have nothing over here. I2 comma capital C, we got E5, right? One by one, as I told you how to see this. See the previous step and do this particular thing. It's very simple. I3 comma small c, we got S3, and I3 comma small d, we got S4, and we have nothing in dollar, we have nothing in capital S, and we have E6 when we compare I3 comma capital C. We got E6, that is iteration number 6, right? I4, I5 and I6. Let me show you here. I4, I5 and I6 is a null state. We cannot able to do anything. It was already ended. So what we need to do is, it is an end state. So we need to take all this particular iteration. Say for example, what is iteration number 4? We got is C tends to D. What is iteration number 5? We got is capital S tends to capital C, capital C. And what is I6? We got, that is capital C tends to small c and capital C. It's very simple. Now we need to take follow for all of this. As you know, first and follow, how to find this first and follow. We did this in predictive parser also. So we need to take this particular thing. So now we need to find follow for capital C and follow for capital S. So we need to find all this follow, and we can able to get only two things over here. That is all the symbols. That is only terminals, right? We got a terminal here. Number 1 is dollar, and number 2 is small c and small d. So this is what we got, all of this. So we need to take follow for capital S, and follow for capital S cannot be done because follow in the sense we need to see in the right hand side, and there is no capital S in the right hand side. We need to take all this process and we need to end up over there, right? So in this particular thing, apply rule number 4, that is, take all this terminal term and apply in iteration number 4, iteration number 5, iteration number 6. So what is iteration number 4, 5 and 6? We can able to see that. I already shown you what is this particular grammar is all about. See here, you can see here, this is, let me show you. This is iteration number 4. So C tends to capital C capital. This is iteration number 4. This is I4. And then, sorry. Now you can see that. So all this particular grammar, so we have already mentioned row 1, row 2 and row 3. These are all the iterations we got, right? So this is iteration number 4, this is iteration number 6 and this is iteration number 5. We got 3 symbols, dollar, small c and small d. Apply this row numbers in all of this according to this particular iteration numbers. For iteration number 5, we need to apply R1. Iteration number 6, we need to apply R2. Iteration number 4, we need to apply R3. R represents reduction. That means you can able to see there is nothing values has been moved over here. This is the finished state, right? I4, I5 and I6. This is a finished state. Nothing can be moved. So we used to call it as reduction. We know what is all of this, right? This is iteration number 6. We got this as iteration number 6 as R2. And iteration number 5 as R1 and iteration number 4 as R3. So these are all the things we need to apply over here. It's very simple now. So we got small c, small d and dollar. What is iteration number 4? Iteration number 4, we need to apply R3, right? So we are going to take this small c, R3, small d, R3 and dollar is R3. So this is a reduced state, right? So we need to mention that reduced, as I already discussed you and I told you how this can be happen, right? So iteration number 5, and the row number or reduction rule is R1. So where we need to apply, I already shown you all this particular symbols, whichever the symbols is applied. So this represents R1, R1, R1. For iteration number 6, we have R2, R2 and R2. This is how this step number 3 has been established. Now this production, that is using all this production, we are going to construct a parsing input string, right? So this is a parse table we have been constructed. This parse table is going to be a heart of your step number 4.